Alright, so let's solve a problem in this section. It's problem number 15-7. Let me read out the problem. It says, a 1300 kg stationary car whose brakes are not applied is subject to a force of 5 kilonewton. A force of, so that's the mass, force of 5 kilonewton. I'm going to write it as 5000 newton. For 2 seconds, time is 2 seconds. When truck is near, when struck in the rear by another car, what velocity is imparted to the car if the car that was struck had weighed 50% less? What would have been its velocity? Okay, so first we gotta find the velocity of this car, right? So we'll use our formula, which is F times T is equal to m times delta V. So impulse is equal to mass times the change in velocity. Okay, so force is 5000 times the time is 2 seconds. Mass is given as 1300 and delta V is what we have to find out. Okay, so running the numbers, we have delta V as 7.69 meters per second. Okay, now it says what happens if that car weighed only half the half of 1300. So basically it's the same problem. So here we have 5000 times 2. Instead of 1300 we have 650 times delta V. So here you see delta V would be equal to 15.38 meters per second. Okay. Next problem we're going to look at is 15-11. Okay. I'll read the problem out. Determine the force required to bring an 8-ton truck traveling at 50 miles per hour to rest in 5 seconds. How far does it travel? So the weight is 8 ton, right? And the initial velocity given by u is 50 miles per hour. So let's go ahead and convert it right here. So 50 times 5280 over 3600, so that gives you 73.3 feet per second. Okay, now the final velocity, because it says to rest, final velocity 0 in time equals 5 seconds. Okay, so we know acceleration is v minus u over t. So 0 minus 73, 0 minus 73.3 over 5. So that gives you a deceleration of 14.67 feet per second square. Okay, now so that's obviously negative because it's deceleration. Right, now we need to find the distance it travels. Again, this is nothing different than the problems you've done before. Okay, we can use v squared minus u squared is equal to 2s, which ties the final velocity, initial velocity, and the acceleration and distance. Okay, so final velocity is 0, initial velocity is 73.3 squared, 2 times negative 4.67 s. Right, so when we do this, we get the value of s as 183 feet. Okay. Right, now going back to finding the force, right? So force times time is equal to mass times change in velocity. Okay, so the force we need to find out, the time is 5 seconds, mass is 8 tons, so times we have to do 2000, right, to convert it into pounds, right? But that's the weight, and we need to convert it to mass divided by 32.5. 2, okay, times the delta V, we already know 73.3. Okay, therefore we went from 73.3 to 0, so the delta V is still 73.3. So what do we get when we do all of this? We get force is equal to 7284.5 pounds.